In this video, we'll look at exploring congruent triangles, which is simply just looking at the formal definition of what it means for triangles to be congruent, which should tie into what we already know about congruence. And then what we'll do after this is we'll look at what do we really need to know if two triangles are going to be considered congruent? Do we have to go through all of these formal steps? And the answer will be no, but today we'll get a good look at what it truly means. So just to remind you of congruence, the word congruent, remember, implies that equality. So two shapes are going to be considered congruent if and only if they have the same side lengths and angle measures. So when we talk about two triangles being congruent, we think of triangles having three sides. And so in this diagram down here, we see that the two triangles have three congruent sides, and their angles are also supposed to be congruent. And so with angles in a triangle, we know that the sum is 180. And if we find these missing angles, which we should always do for good practice here, we see that 60 and 50 is 110. So this missing angle at B must be 70. And angle P in the second triangle, 60 plus 70 is 130. So the missing angle is 50. And so from there, we see that not only do the two triangles have three congruent sides, but they also have three congruent angles, two angles of 50 degrees, two angles of 60 degrees, and two angles of 70 degrees. And not only that, but these angles' locations are in the same position. So if you look at 50 right here, you'll notice that it is between the marked sides of 2 and 3. So the side that has 2 markings and the side that has 3 markings, the 50 degrees is in between that. Well, the same is true for this other 50-degree angle. It is also made by the sides that have 2 markings and 3 markings. So that's the other thing. These triangles, when they end up being copies of each other, which is this idea of congruence, they're the exact same triangle in two different locations because they have all the same sides and all the same angles. Everything's going to be in the same positions. So when we look at these two triangles, we can talk about their points corresponding to each other, which is what's being said in blue up here. To name these two triangles as congruent, we just figure out which vertices are aligning to each other. So, for example, angle A is 60 degrees, angle K is 60 degrees. So these two vertices correspond. Same would be true for the others. B is 70 degrees, so R is also 70 degrees, and we see that. And then likewise, C is 50 degrees, and P is 50 degrees, and so C and P correspond. I'm pointing that out because when we list a congruent statement, we want to know in our statement which points are aligning to each other, because that's going to tell us which angles have to match, and as well as the sides. So if we look here, we see triangle ABC is congruent to triangle something. Well, that something has to be triangle KRP, because like we said earlier, angle A is congruent to angle K, angle B is congruent to angle R, and angle C is congruent to angle P. So it tells us all that, which I've listed out for you here. It also tells us which sides are going to be congruent, because the order listed here, if we look at 2 letters at a time, we're naming a side of a triangle. So if we look at the first 2 letters, we're talking about side AB, which is over here. And you notice AB just has the single marking on it. Well, if we look at the first 2 letters in our next one, it should do the same, to where KR also just has the one congruent marking, and it does. And so you can look at the first 2, you can look at the last 2. So if you look at BC here, which has 2 markings on it, and you look at RP here, it also has 2 markings on it. And then lastly, where's your third side? Well, you can look at the first letter and the last letter, which is AC. And you see that side AC has 3 markings on it, and likewise side KP in our second triangle also has 3 markings on it. And so now we get this idea of congruence, meaning that each of the angles will have to match, and each of the sides in one shape will have to match a side in the other shape. Essentially, congruent shapes are just copies of each other. So ABC, and KRP are 2 identical triangles. It's just one has been shifted over to a new location. Well, let's try to apply that then with congruent statements here. We see 2 shapes. In this one, all 3 sides are, this is quadrilateral. So we're going to stick with triangles for the most part here. But what we're learning can apply to any shapes we look at. So this is a shape with 4 sides called a quadrilateral. And when we look at it, we do notice that the side lengths are given. We have 2.99 here, 2.74 and 4.2, and 3.55. Okay, so something we can do is we can start maybe getting a visual by coloring these sides. So what I've done is for the sides in this triangle, AB is in green for 2.99, BC is in red for 2.74, DC is in blue for that length of 4.2, and I've left AD, that length of 3.55, in black. And if I highlight those same colors in my second picture, you'll notice that I used green again for 2.99 and red for 2.74 again, and blue for 4.2, just like we did in the first diagram. What that's going to do is going to help me realize which sides correspond. So I see that side AB is congruent to side GH. So those 2 are going to correspond in my statement. Likewise, BC is corresponding to HI. They are both 2.74. Okay, so I look at this one, this statement. It starts with BC, which you'll notice is in red, which corresponds to HI. So I'm going to keep track. BC is in red. And then the next 2 letters in this statement are CD. And so you'll see the order of these letters right up here are referring to my red side BC and my blue side CD, first and second. And so when I write my next statement, I'm going to need to do the exact same thing. So the order I list the second figure will have to be HIJG, because just like we said, BC was in red, HI is in red. They both have the same length. And the second 2 letters, the middle 2 letters in the first one are CD, and the middle 2 letters here are IJ, which are both in blue. And so what we see now is that the statements are lining up the corresponding sides, and that's what it should do for me. And so I can see here that we have the correct statement. And from there, I also know which angles are going to have to be congruent, because B is listed first and H is listed first. So I know that angle B and angle H are going to be congruent angles. So here's angle B, for example. Here's angle H. They would have to be congruent, and you can notice which 2 sides create those angles. It's our green and red side here, and it's also the green and the red side here, which it should be, because these 2 shapes are just copies of each other. That's all they are. So whatever happens in one should happen in the exact same way in the other. Okay, so that's a way to think about it with sides. We can also do it pretty quickly with angles. It doesn't take too much effort here. So we have triangle ABC is congruent to triangle something. We do see the triangles have all 3 angles that are the same, which doesn't actually prove that these 2 triangles are going to necessarily be copies of each other, but we're being suggested that they are with this statement. And so if we know the triangles are congruent already, to list it in the correct order, we just look at our first letter A and see its measure, which is in this picture 50.84. So we just need to find the other angle that says 50.84, which is Z. And then we go to B. Angle B is the 76 degrees here. And so we find the other angle at 76 degrees, which is X, which leaves us with only 1 letter left, the Y. And we do see that angles C and Y have the same measure. So there's a way to name it using the angles and a way to use it naming the sides. But in both cases, they do tell us which angles are congruent, and they do tell us which sides will be congruent. All right, so let's try to apply this here. Down here, we have 2 figures. We are told they're congruent. You see that highlighted here. DEFG is congruent to SPQR. And so we notice we're solving for some variables here. And the letter X, for example, is listed on side QR. And we should be able to figure out which side it's congruent to. Since QR are the last two letters listed here, we look at the last two letters here, which is FG. And so out of all of my options, I see that this is the one I'm supposed to use. And let's go back to what congruent means. Congruent means to be equal in measure. And so equal would mean that 2x minus 4 should equal 12. And if we want to solve for that, it is simple as saying that 2x minus 4 equals 12. And then we can solve pretty quickly there to figure out that x is going to equal 8. Similarly, for y, which is one of our angles, it's inside one of our angles. It's in angle Q. And so we just need to figure out which angle has to be congruent to this one. So Q is the third letter listed here. We go and look here. F is the third letter listed here. And so that way I know that angle Q has to end up being 68 degrees. So we're going to figure out what variables are going to force this angle to be 68 degrees, just like angle F. Well, to do that, we'll set these equal, which is what congruent implies, equal measure. And then we need to solve for y. And at first we think we can't do that because we have this x, but you remember we just solved for x and that still applies here. So x is going to equal 8. And once we substitute from there, we should be able to solve for y pretty quickly. And solving a relatively simple equation, we get y equals 10. Okay, so that is purely just using the idea of what congruent means. Okay, figuring out which sides are congruent, which angles are congruent. In both cases, it means that those two components are equal to each other. And so we set them equal. Okay, just a couple last things to talk about then. Congruent triangles here, part of our job sometimes is to actually explain why they're going to be congruent. So the formal definition is two triangles are congruent if and only if each of their corresponding sides and angles are congruent, which is what we've been talking about. We will consider two triangles to be congruent, two triangles to be the same triangle, just copies of each other, if we know all their sides are congruent, which we already see in this diagram. All three sides in each triangle are marked. So we see all the sides are the same, but do we know if all the angles are exactly the same? Okay, and so that's what we're going to show next. We're going to explain why. So I have 3 blanks here to show which angles are going to be congruent, and I have the reasons already listed. So we've been practicing for a while justifying our thoughts, and we're going to keep doing that here today. We need to explain why these angles are going to be congruent based on things that we already know, hopefully. So for example, the first case, it says definition of vertical angles. We should know what vertical angles are. They're those angles across from each other at an intersection, which would be the two angles at T. And we can't call both of them T, right? That would be confusing. They're two different angles. So we have to go back to naming these using 3 letters. And if you recall, when we do that, T, since it's the location of the angle, it's going to be the vertex of the angle, is going to be the middle letter in both cases. And then to complete naming the angle, maybe you look at the left angle first. The corner is at T, and it opens up toward the letters P and S. So P has to go on one side, S has to go on the other. Same over here. The angle is at T. One side opens towards Q, the other opens towards R. And so there you go. So those two angles are congruent because they are vertical angles, which are always congruent. Something else we talked about is parallel lines, and you might notice that QR has one of these arrows on it, so does PS, implying that these two lines are parallel. And we have lines connecting them, those transversals. We actually have 2. We'll just focus on one at the moment. And I have, if 2 lines are parallel, then the alternate interior angles are congruent. Well, hopefully you remember interior means to be between the parallel lines, inside of them. To alternate means to switch sides of the transversal. So if you look at angle S right here and follow this transversal all the way across to Q, you'll notice the angle at Q is underneath the transversal while the angle at S is above it, which is the idea of alternating. So we have alternate interior angles here, which we can name using just a single letter, S and Q, since those are the only angles obviously located at those points. So we know S and Q are alternate interior angles with these parallel lines. They must be congruent. And we could use the same reasoning here for the angles P and R, but I want to look at a new idea. Something called the third angle theorem, which says if two angles in one triangle, so two angles here, are congruent to two angles in a different triangle, then the third angles are going to have to match each other. The third angles will also have to be congruent. And intuitively, I think it makes a lot of sense, but let's actually get a visual as to why. So you might notice down here, we have a triangle ABC with angles of 35 and 88. We have triangle HIJ with angles 35 and 88. So they have the same two angles to start. Are the third angles going to have to be the same? And you might think, why? Why does angle C have to be congruent to angle J? And the reason is pretty simple. It's because the angles in a triangle, no matter what triangle it is, all three angles have to add to 180 degrees. And if that's the case, then we should be able to find the missing angle here and see what happens. 88 plus 35 is 123, which gets us an angle measure of 57 degrees. And you can do the same thing over here for angle J. Add those two angles together, 35 and 88, and you get 123 again, which, since we're using the same idea, we're going to get the same angle measured here, also 57 degrees. So yes, all three angles will have to match. So that's something we can say is always going to happen in a triangle. If two angles are the same, then the third angles will also have to have the same measure. And so for that reason, we do see that angle P is congruent to angle R, and we can mark them that way. And you see that in our diagram now, we have all three pairs of angles marked as congruent and all three pairs of sides marked as congruent, which is the true definition of congruence. All sides and all angles will be the same because the two triangles are essentially copies of each other. And once you're able to show that, you can make that strong conclusion. These triangles are congruent. And so what we will do here is just a few times go back to some of those proof setups. You did an informal proof here, being a little more formal about it slightly. This organizational tool using two columns is something else we use. So we are going to prove that these two triangles in this picture are congruent, similar to the diagram we just saw, except this diagram has some parallel lines shown. This one does not, so we're going to make sure we don't use that idea of parallel lines, but we should have enough information still. And so what you might recall is a lot of times in these proofs, you're going to be given information. There's no reason you should just know everything out of the box. The idea is if you are provided with this information, or if you know this information for some reason, can you then go far enough to recognize that everything else must also be true? And so that's what we're going to start with here. Sometimes that given information is listed up above. It's directly in the table for you. So let's see what it is we know. It looks like we are told that angle 1 is congruent to angle 2. So a good thing is up here to list that out. Angle 1 congruent to angle 2. Segment JK is congruent to segment PM. Okay, so JK is here. Put a dash on that. PM is here. That was given to us. And then we're also told that segment JL is congruent to segment PL. Okay. JL here, PL here. All right. So far it looks like we have three things marked as congruent. And rather than call them things, I'm going to make a list here. We recognize that triangles have three sides and three angles. So what have we shown so far? The first thing we did is we showed a pair of angles are congruent. So I'm going to mark that out here, one of these out. And then after that, we were given that a pair of sides are congruent, and then a second pair of sides are congruent. So I'm going to mark those out. What I'm showing over here is we will know that these two triangles are congruent when all three sides are marked as congruent and all three angles are marked as congruent. So far we're halfway there. We have two of the sides and one of the angles. Now we just need to show that another pair of sides is congruent and another pair of angles is congruent. So where do we go from here? Well, the first thing is make sure you use all of your given information. We do have one last piece here. We are told that L bisects segment KM. So point L bisects segment KM. And if you remember what bisect means, it means to cut in half, right? So when we see the word bisect, that means to cut in half. So in other words, segment KM has been split in half. Well, what would it mean to split into two equal halves? It would mean if you take KM and break it into two pieces from KL to LM, that those two pieces would be the same length. And so these segments KL and LM are congruent to each other. So let's make a note of that, which is what a proof does. It just lists out information that we know. Segment KL is congruent to segment LM. You notice that's another pair of sides in the triangle, so we'll mark that out. And so we've done that task. We've now officially shown that all three pairs of sides in the triangle are congruent. So now let's give a reason for that. The word bisect told us this, and we bisected a segment. So the reason, pretty simple. This is the definition of an angle bisector. Oh, sorry about that. Definition of a segment bisector. We've split a segment in half. So we recognize, in other words, what the meaning of bisect was. Okay, so we have two pairs of angles left to go. And we can probably visualize it has to be angles K and M, or the two angles at L that are going to be congruent. And we actually know a pair of those. We don't want to guess at this, but if we use properties we know, maybe some that we've already discussed today, we do know that these two angles at L should be congruent. And let's think about why again. They're opposite of each other at a vertex. That would make these vertical angles, just like we said before. And so now we know that angle JLK is congruent to angle PLM. And how do we know that? It's because we know what kind of angle they are, which is special to us. That is vertical angles. And so I'll just list that out as definition of vertical angles. So we have another pair of angles that are congruent. I'll mark that out. And you'll see now we just have one last thing to show, this last case of angles. But if you recall before, when we have two angles that are the same, the third angles will also have to be the same. So I'm not guessing about our last two angles because we know that the angles in a triangle have to add to 180. When two of them match, the third pair also has to match. And so, yes, the last thing we do know is that angle K must be congruent to angle M. Because of what we listed up here, we called it the third angle theorem. And so that's what I'll put, angle K congruent to angle M. And the reasoning is exactly what we said before. So we have all three pairs of angles congruent. Mark that out. All three pairs of sides congruent. We've officially shown that everything in these two triangles is congruent. And so these two triangles are congruent triangles. They are copies of each other. And that would be our reasoning here. We know these two triangles have to be congruent because we've shown everything about them is congruent. So in some resources, you might see this listed out as definition of congruent triangles. You may also see something similar to this one. Looks a little nonsensical. It says if sa, then two angles are congruent. And it actually says if SA. In other words, if you have shown that all three pairs of sides are congruent and all three pairs of angles are congruent, then the two triangles are congruent. Okay, so that should be able to get us through the proofs for the most part. We're going to look for bisectors, vertical angles, third angle theorem, and definition of congruent triangles by showing all the components are congruent. I did attach a reference sheet here that we don't need everything that's in it right now. We actually don't understand what all of it is yet. But I did highlight some things. If you are working with sides, working with segments, some things that you want to pay attention to is what information has been given to you. Bringing back something we haven't used, but we have talked about. Reflexive properties simply says something is congruent to itself. And so in this picture right here, we have two triangles that share a side. Well, this segment is a side for each of the triangles. So we can just mark that triangle as that segment as congruent to itself, meaning that segment in both triangles is the same. So there might be a property we look for today. Also down here, we should know that midpoints split a segment in half. And so we'll have two equal halves if we get that word. A bisector, same deal. And then if you're working with angles, one, check your given information. Look for vertical angles today. Look for that third angle theorem. And then also look for parallel lines. Those alternate interior angles are most common. We could technically use corresponding angles in some cases and alternate exterior, but the alternate interior are going to be most common to us.